Okay, in this video we'll learn about annuities. We'll learn what annuities are and how we can calculate the present values using this example over here. So we're given that May is offered a project which promises her $1,000 every year for 8 years. We know that she's supposed to receive her first payment 1 year from now, that is in year 1 instead of year 0. The interest rate is given to be 5%. We need to figure out the present value of this project. So let's visualize the timeline first. As you can see, May receives her first payment in year 1 instead of year 0, which is the present. And all of these payments are equal to $1,000. So she gets her first payment equal to $1,000 in year 1, and again in year 2, again in year 3, and this will continue till year 8. Now this stream of payments is actually an example of an annuity. Now what is an annuity? An annuity is a regular stream of equal payments that last for a fixed number of periods. Now let's compare that using our case that we have over here. You can see that the stream of payments is regular because you get them 1 year apart. May gets a first payment in year 1, and then in year 2, and then in year 3, and continues like that. So it's a regular stream, and you can also see that all the payments are equal to $1,000 each, and they last for a fixed number of periods, which in this case is obviously equal to 8. By now you can hopefully see the difference between an annuity and a perpetuity. A perpetuity gives you never-ending payments, and an annuity only does so for a limited or a fixed number of periods. Alright, now that we know what annuities are, let's get back to our question over here and figure out the present value of this project or the present value of this particular annuity. And how do we do that? Well, we discount all of these payments separately and simply add them up. So the present value for year 1, we have 1,000 divided by 1 plus the interest rate, which is given to be 5% or 0.05 raised to the power number of periods. And since it's period 1, so it's just going to be raised to the power 1. And similarly for year 2, we have 1,000 divided by 1 plus 0.05 raised to the power 2, and this will go on till period or year 8. So we have 1000 divided by 1 plus 0.05 raised to the power 8. Now you can notice that 1000 is common in all of these terms, so we can just take that out, and within brackets we have 1.05 plus 1.05 raised to the power 2, and this will go on till raised to the power 8. Now all we need to do is figure out the value of this tedious expression within brackets, but do not worry, there's actually a formula for that which will simplify the process. This term in brackets is actually equal to 1 by r minus 1 by r into 1 plus r raised to the power t, and this comes from the present value formula of an annuity, and we'll take a closer look at that separately in a minute. For now we can just substitute all of these values and forget our desired answer. That will be equal to 1000 into, again, r is just your interest rate and t is the total number of periods. So we have 1 by 0.05 minus 1 by 0.05 into 1 plus 0.05, and total number of periods is equal to 8. And you do all of the math and you get the total value to be equal to $6,463. Alright, now let's take a closer look at this present value of an annuity formula. Here C is the payment that you get in period 1 or in year 1, which in our case was equal to $1,000. R is the interest rate or the discount rate, and T is the total number of periods, which in our case was equal to 8. This expression within brackets is sometimes referred to as the present value interest factor for annuities, or PVIFA for short. Takes the parameters, the interest rate and the total number of periods. You'll probably find a separate interest factor table behind the back of your textbook, which provides the interest factor for various combinations of interest rate and total number of periods. And so if you're given this interest factor, all you have to do is multiply it with the payment that you get in your first period, and we'll have the present value of an annuity. Now I'll make a separate video on proving how we got this present value formula in the first case, but until then, hopefully now you know what annuities are, and now you can calculate the present value using this formula over here. Alright, I'll see you in the next one.